we are completing the square to start to finish. We're asked to solve for the roots in simplest form by completing the square. Roots is another name for x-intercepts, or where y is equal to 0, or solutions. So all of those things mean the same thing, as basically solving for x here. If this were a y, and I replace that y with a 0, that would be the x-intercepts. So basically we're just solving here, and we have to use the complete the square. I'll go ahead and show you my version. All right, so first thing I would do is write out the general form, ax squared plus bx plus c. So it's already in that form. So that means b is 16. We need that number. So the first thing I'm going to do is I'm going to use the complete the square number. Complete the square number is what? Do you remember? b over 2 quantity squared, which is going to be, in this one, is 16. So that's going to be 16 over 2 quantity squared. 8 squared is 64. All right, so that's going to be the number that we're interjecting into this equation. So here's what I recommend and how I do it. It's different than his technique. You can always look through what he does to follow his, his methods, whereas I'm going to show you an alternate style. So x squared plus 16x. You leave a space here. You still have a plus 19 equals 0. Okay? In this space is where we're going to interject the 64. Now, for the delta math, he adds it to both sides. For me, I add it to complete the square here, and then I subtract it, which is totally legal. So when you add something to both sides, that's hasn't changed anything. If you add and subtract the same number, that's like adding 0, which does not change anything. So what that does is it immediately sets up this as our perfect square binomial. So what two numbers multiply to be 64, add to be 16? 8 and 8. 8 times 8 is 64. 8 times 8 is 16. At this stage, we've seen it already. I'm going to go ahead and just go straight into my perfect square binomial. X plus 8 times x plus 8 is what that turns into. Now, this is where it helps, is we just combine like terms right here. We got negative 64 plus 19. I don't want to make any mistakes. Negative 64 plus 19 is negative 45. Negative 45. Oh, let's put it right here. Minus 45. All of this still equals 0. Okay, so then we're solving for x at this stage. To get x by itself, I get rid of all the plus and minuses first. So I'm going to add 45 to both sides. Add 45. I get x plus 8 quantity squared equals 45. Quantity squared. To get rid of the square, the opposite of square is square root. What you do to one side, you do the other. Don't forget what? The plus or minus. This now undoes the square, which leaves us with the x plus 8. And we get plus or minus the square root of 45. So this simplifies. So in our side work, we want to simplify it. Here's my technique. So I take the 45 and I break it down. So that's 5 times 9, and 9 is 3 times 3. So the square root of 45 is the same thing as the square root of 3 times 3 times 5. That's 9 times 5 is 45. And then my trick is I pull out pairs. There's a pair of 3's, so it comes out as a single 3, and what's left is the 5 inside the radical. Okay, so all of this turns into 3 radical 5. To get x by itself, we subtract 8, do it to both sides, and I get x equals negative 8 plus or minus 3 radical 5. And that completes it. We're done. So this answer is -8 plus or minus 3 times square root of 5. So just going through the process here one more time. I like writing out the general form above it so we can see what each part is. We focus on the number in front of the x, which is 16. The complete the square number is b over 2 quantity squared. So that's our b is 16. We simplify, and our complete the square number is 64. We have to interject that or input it or put it in our equation, usually next to the part that we're completing, which would be this part right here that gets completed as a square. So there's the 64. I add and subtract it to keep it balanced. And then we still have our plus 19, and it all equals 0. This part turns into our perfect square binomial, and we combine like terms here and solve for x and simplify our square root to make sure everything is in its simplest form. Okay, so he's doing it his way where he moves the constant over, then he adds 64 to both sides. Same structures, so feel free to use whichever one you like. He does the harder version of simplifying your square root, where you're identifying perfect squares embedded inside of the square root, which is very difficult if you struggle with it. I really recommend my method. It breaks it down into simpler pieces that are easier to digest, where you're not identifying perfect squares. Yes, same answer. Problem types, irrational solutions is the tough one that I just did. Non-real means you're going to have the I floating around. Rational should be easier, where you get fractions or whole numbers. So we've seen all the structures now. It's just a matter of getting through it.